You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Okay, welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
And I'm Doug Mason.
And today we have three folks from Michelin here to join us in a discussion. We got Carl Remick, business model leader, Bill Woolmsley, product category manager for tires, and Calvin Bradley, product category manager for Aero. Hey, thank you guys for joining us.
Thank you, Mike. Yeah. Thank you, Doug.
Very
glad
good
to
to have
be
you
here.
guys here. Again, just to remind you, we're live from TMC 2020, and so we're enjoying the show, and you guys obviously are showing what you've got here, and we're, again, very thankful that you guys are coming along to tell us more about truck tires and other things.
Well, thanks a lot for the invitation.
So continue on. You were talking about the trailer specifically. What are some of the aspects of the trailer that...
And what does Michelin, what's Michelin contribute to all this?
So the energy guard system is a full solution for the trailer, and we sell all the components you need in order to meeting the greenhouse gas regulations. So a big element of the greenhouse gas regulations on the trailer side is the aerodynamic packages that you can have. With the skirt as the first part, every skirt is going to help shield the bogie tires from having air hitting them hard.
When you say bogie tires, what does that mean?
So the tandem tires, the tires on the trailer.
Okay.
The tire and assembly.
Okay.
Almost every skirt's going to do that about the same. It also will affect how the air travels around the tires and affect the back of the trailer. We also have some aerodynamic mud flaps, and mud flaps are sometimes forgotten for aerodynamics, and because aerodynamic mud flaps are typically going to be more expensive than a very inexpensive mud flap, but they pay for themselves very quickly. They're definitely worth the cost because they allow air to pass through.
Are they like cross-hatched or something? Is that the...
Yes, so most of them in the industry will have slots so the air can pass through easily. Ours are a little bit different in they have slots that have variable spacing and they're angled down, so not only do they reduce the energy of spray going through them, but they also knock everything down toward the ground. So it reduces the spray and you prevent having water shooting off the side of the mud flap, which can affect the vehicles around the truck and trailer.
Okay.
Never fun for anybody going by a truck.
It is not fun.
No, I always have to put my windshield wipers on high when I go out behind a truck. Well, thank you. That was very helpful. Anything else with aerodynamics?
So there's three more parts. We have some airfoils, so half airfoils on the top and sides of the trailer, and that helps wrap the flow around the back, and mainly it's there for stabilizing that air at the back of the trailer. So it's doing similar function to what a boat tail does, but it does it with a lot less intrusion. So there's no moving parts. There's nothing to deploy, so the drivers can forget that it's even there. And then the last one, we have a unique innovation, which is a non-traditional spoiler. It's a little V shape on the back doors, and that helps trip the airflow that's flowing down the back of the trailer and keep it from interfering with airflow coming underneath. A lot of complexity, but all of those pieces together become kind of greater than the individual sums.
So let me make sure I understand here. Number one is what your system is doing. It sounds like you're really focusing first and foremost on that air that gets trapped behind the trailer.
Yes.
And then you're also looking at the air that is traveling underneath the trailer. Those are the two big areas that you're addressing with this aerodynamic system that you've got out there. And mostly it's about maintaining that laminar flow where it needs to be and keeping the dead air where it's sort of trapped in place.
Yes.
Okay, and this reminds me when a few years ago there was it's very similar to what was found a few years ago on pickup trucks. They said everybody was taking the tailgate off and putting the
putting the nets on there.
Putting the net on there to let the air go through, and that actually reduced aerodynamics because what was happening is once you put the solid door, then you get this dead air. And it's a naturally aerodynamic. Now the air is dead, and it's almost like a perfect teardrop that's created, and it's perfectly aerodynamic by the air. The air is actually helping. And it looks like you guys are sort of doing the same thing. You're getting the air to work for you rather than to work against you.
That's an excellent analogy. The trucks were designed to work with the tailgate up, and dropping them and removing them defeated the actual original intent.
Right. So very helpful. Great. Thank you.
So I guess as a general point, though, just aerodynamics as a whole is something that fleets should be looking into. There's a lot of advantages to it from greenhouse gas going forward from that standpoint, but the practical aspect is fuel efficiency. And so it's going to be an evaluation on what that fuel efficiency and the cost of putting this all in place is, but it's something that the fleet should be looking at.
Yes, so for the aerodynamics, the energy guard system, which again has no moving parts, is saving about 10 gallons per 1,000 miles. Mm-hmm. So it's a very large contribution to the bottom line.
Well, and that's another thing that we were discussing just before we got on the air here, is the fact that a lot of people look just at the fuel mileage. But really what it comes down to is, in trucking, you're moving something. How much does it cost per gallon of movement of the parts that you're trying to move, as opposed to the fuel mileage of the truck overall?
Well, and that gets into wide base, right? The big thing that you want to talk about there is you want to be talking about wide base wheels. When you start getting into the wide base, you're dropping the load, and once you drop the load, now you're increasing the carrying capacity of the vehicle. That additional carrying capacity actually gives you double benefit.
That's right. Yeah, Mike, you hit it on the head. The new generation wide base singles, they've been on the market now approaching 20 years, but the fundamental value proposition for fleet customers is the same. And like you said, it's a reduction of weight, reduction of load, so you can carry more load. So we like to say, hey, you're reducing your weight because you're going from 2 tires to 1 tire. You're going from 2 wheels to 1 wheel. That additional weight savings, which can be about 800 total pounds for a fleet, allows them, when they're not maxed out in terms of cubage, right, to haul more. And we've seen a lot of fleet customers go that way. The other reason people have gone to it, this has been true since the beginning, going to next generation, new generation wide base singles, is the fuel savings, right? You can further your fuel savings even more with a wide base tire on your drive and trailer axles than you can with duals. Bill, am I missing anything there?
No, I think the two go hand in hand, too. So some of the fleets, as Carl mentioned, are looking for weight savings, and some focus more on the fuel. But for every 1,000 pounds of weight that you save, you're saving up to 1% more in fuel as it is. So the weight savings kind of doubles up on the fuel, so you get a double benefit there. And I think you hit on that right at the beginning there.
So one of the things that I'm curious about, I've heard that wide base wheels reduce rolling resistance. This is something that I've heard ever since wide base wheels, shortly after wide base wheels came out, right? That, hey, you get this benefit of rolling resistance. Maybe you could walk us through how that is. What is exactly going on there? Why does a wide base wheel reduce rolling resistance versus 2 duals, for example?
The biggest advantage is there is you have 4 sidewalls versus 2. Which minimizes the amount of deflections that you're getting when you have 2 sidewalls. So there's a huge inherent advantage by replacing 2 tires on each wheel end with 1.
Okay.
Yeah,
okay.
So that's a big
does it have a same tire footprint then? Is the footprint
and it depends on which tires you're comparing, but the footprint is similar. It's not the exact same footprint, and it'll depend on the tread design. So.
Okay, and that's where I was getting a little bit confused, because I was always thinking of the tread compression as being the biggest energy loss. And if the footprint is the same, then I'm thinking just, okay, well, that's about the same tread compression that was with duals.
Yeah, so we have some treads that are almost identical between a wide base and a dual.
Okay.
But that's where it's more than just the tread itself. It's the whole casing. It's the whole tire as a component.
So I learned something.
Yeah.
So, okay, great. Thank you. One of the big things that's out there in the industry, when you talk about wide base, people talk about wear. You hear about a lot of fleets moving away from wide base because of the wear problem, especially in trailer applications. You guys want to talk about that a little bit?
Yeah, so one of the things we have here at the show, we have a new trailer tire. Trailers as a free-rolling axle position, whether it's dual or wide base, are sensitive or susceptible to some degree to irregular wear. So our job as a tire company is to fight that, to give you the same wear, whether you have dual or wide base, that a fleet would expect. So we have a new tire here at the show, X1 Line Energy T2, that the entire focus of that tire is to reduce its sensitivity to irregular wear. So I think we're kind of at the point where whether it's dual or wide base, they're both doing it.
Now that tripped off your tongue pretty quickly, so you may want to say that a little more slowly so people.
Oh, sorry about that.
It's okay. So what was that again?
The tire?
The tire.
The tire here is the X1 Line Energy T2. So
okay.
It's our second generation Line Energy T trailer tire.
It's obvious you've said that a few times, and it just sort of pops off with no problem.
Mike, one thing I'd add to that, and Doug, is realize, Bill touched on it, but the trailer axle's a free-rolling wheel position, right? It's often running variable loads, right? Fully loaded, sometimes empty, sometimes something in between. There's 2 to 3 times as many trailers in the market than tractors, so by nature, they're sitting in different yards across the country, across the continent. Because of that, they're often the forgotten wheel position in terms of maintenance, right? So just by their nature alone, trailer tires are more susceptible to irregular wear.
Right.
Whether it's dual or wide base, you'll have that issue. And that's what fleets tell us, right? Our next generation X1 Line Energy T2 takes that into consideration. So our engineering group, our designers put into place into that tire that specific goal, help it wear normally, because that's what the fleet customers are seeing, right? And a trailer tire, it's not always attached to the tractor, right? So they don't actually know how many miles they're getting, but they know when they see irregular wear. That's the real pain point.
Yeah, they watch those dollars.
And that's what we try to focus on going forward.
Just to focus on that a little bit is, what are some of the things that create that irregular wear? I mean, what you say you're designing a tire to eliminate it, but there's got to be some sources for it that are occurring. And is there something that the fleets can be doing as well to address that from that side?
Yeah, absolutely. That's a great question, Doug.
So I think Carl hit on one of the big things there is just varying degrees of load where you're not adjusting the pressure to carry the load. So if you go out and if you have a fleet that goes out and back and they're hauling fully loaded there, that's one pressure required for the tire. If they come back empty in order to get the optimum tire wear, you should lower the pressures to match the load that you're carrying. So that'll start to induce the sensitivity to irregular wear. Generally, you see it start on one shoulder or another, and it can spread across the tire.
Okay.
Maybe this is going to get a little too technical, and if it does, we can cut it out. It seemed to me that when I think of a tire being overinflated, let's say you have a full load on the way there, you have the inflation pressure for that full loaded application, and then you're running empty on the way back. In my simple mind, I think of the tire as being a balloon, where you're going to get wear in the middle, but what we actually see is shoulder wear.
Yeah, you'll see it because those shoulders aren't coming into consistent contact with the road, so they're intermittently hitting the road, so to speak. So you're not getting an even footprint of the tread on the road, so those shoulders are kind of along for the ride, so to speak. So that's where you see that cupping start, because it's intermittently contacting the road.
What's happening is you do have a little bit of a balloon effect,
right?
Is what I'm hearing.
It's more of the pressure is in the center of the tread than on the shoulders.
Right.
And then the shoulders, the pressure is intermittent. It's up and down.
Okay, yeah. As the tire comes in, you're getting a little bit of a scrubbing.
Right, in and out of the contact patch.
In and out of the contact patch. When you're at the bottom of that contact patch. Right, you're at the bottom of that contact patch, you get a little bit, it's catching, and then it has to slowly let go because you've got basically almost like two circumferences, two diameters. The diameter in the middle of the tire, and you have a different diameter on the outside edge or the inside edge. And that's what causes that problem.
Right.
Okay, I understand now. Thank you.
Sure.
All right. Well, I think that does it. Thank you, guys. I really appreciate you guys joining us. For our listeners, hope you enjoyed the discussion. We'll see you next time.
Thank you very much, Mike.
Thanks, Doug. Thanks a lot for coming, guys.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.